All right, so today's lesson is over patterns and kinds of reasoning. So reasoning patterns are a part of everyday life. Sometimes you just know something. At other times, you may have observed a pattern and based your conclusion on that. And then there are times when you are certain that an event will occur. Okay, so our first type is going to be intuitive reasoning. So intuitive reasoning is using beliefs and hunches. Intuitive thinking involves sensing that something is true and just feeling sure that you are correct. It is jumping to a conclusion without any real evidence. An example of this is going to be Miss Jones doesn't want her son to go to the movies because she just has a feeling that he will get himself into trouble. Okay, so keywords being has a feeling there. All right, so our next one is going to be our inductive reasoning. Oops. Okay, so inductive reasoning is going to be finding a general principle based upon the evidence of specific cases. It is an educated guess based on data or observations, cases including making decisions based off of polls, drawing a conclusion from a computer lab investigation, or making decisions based off the observation of a science lab. So, since it is not possible to examine every situation, there is always going to be the possibility that a contradiction will be found. Okay, so I'm going to take a second to highlight that. All right, so our example is going to be, after asking the ages of 25 freshmen, Judy reasons that all freshmen are at least 13 years old. Okay, so something that's going to kind of give us away that this is inductive is going to be that she asked 25, but she is referring to all freshmen. Okay, so we're not able to obviously take into consideration every situation. All right, our third and final reasoning is going to be our deductive reasoning. Okay. It is based on some statements that have been accepted to be true. These are rules to reason by. We've got reasoning without any guessing. The conclusion is certain. There is no room for doubt. New facts are deducted from accepted facts. Okay, so our example for this one is today is Tuesday, so tomorrow is Wednesday. Students and teachers consider a wide range of activities as convincing arguments. Some examples include the patty paper, proof of Pythagorean theorem, the conclusion based on observing measurements as you drag segments in the computer lab. Pure mathematicians accept only deductive reasoning as proof. There are two kinds of deductive reasoning. There is the direct and the indirect. And you have experience with both of these kinds. Okay, so we have a scenario down below. Suppose you want to know if your neighbor is at the grocery store. So the direct reasoning here is going to be you going to the grocery store and searching it. You do not see your neighbor, so you can conclude he is not at the grocery store. Our indirect reasoning is you see the neighbor mowing his lawn. Because you have contradictory evidence, you can conclude that your neighbor is not at the grocery store. All right, so that is our final type of reasoning. Now we're going to move into our counterexamples. Okay, so we're going to talk about counterexamples here, but this is going to kind of lead into some stuff that we're going to talk about in our next lesson over conditional statements as well. So mathematicians use both inductive and deductive reasoning. Remember, our inductive reasoning leads to conjectures or educated guess. Our deductive reasoning is applied to determine if the conjecture is true. So it's only going to take one false example to show that a conjecture is false. The false example is what we like to call our counterexample. Okay, so down here, we have a scenario. So for this next example, it's going to clarify the connection to if-then statements. Okay, so real quick, it's not in here, but our if-then statement is tomorrow's lesson over conditional statements. Okay, our if is our hypothesis, is what we like to use that for, and that is going to be this P. Our then is going to be our conclusion, and that is what this Q is going to be. Okay, and then just over here is us determining as its whole statement, is this a true or false? So going back to that, we have Tom makes a promise to his friend by saying, if I find $5, then I will take my friend to the movies. Okay, so these are going to be the 4 scenarios, 4 possibilities they have listed off here. So I'm just going to write that down. We've got number 1, 2, 3, and 4. Okay, so remember, this is going to be that if, and then our Q is our then. Okay, so in that first possibility, we have that Tom finds $5. Okay, so our P is true. Okay, it's going to match up to what they had said earlier. And then he's going to take his friend to the movies. Okay, once again, it matches up with that original. So it's another true for that Q, which makes our final statement a true statement. Okay, in scenario 2, once again, he's going to find the $5. So it's going to be true, but he does not take his friend to the movie. So that's why we're going to change this to a false, because he did not actually follow through with what he promised. And that makes my final sentence a false one. Okay, my conditional is false. And if you look over here, they're kind of giving us this information as well. Okay, so case 2, that Tom broke his promise. That's why this is going to be false. All right, so going back up, we've got in possibility number 3, Tom doesn't find $5. And so since he didn't find the $5, that is false. It doesn't match up to what we have, but he's still going to take his friend to the movie. Okay, so that part of the sentence is still true. Our final statement is going to be true. And we'll see over here that case 3 and 4, they don't actually apply because our hypothesis is not met. Okay, we didn't find the $5. And so that's why when we get into possibility 4 and he doesn't find the $5, so that first part is false. My Q is false. He does not take his friend to the movie. We are actually going to have that true statement over here, but it does not apply because the promise isn't there. Okay, he did not find the $5. Okay, so just a little bit more on that down here on y'all's next page. It says, in this case, the condition is finding $5, and the conclusion is taking his friend to the movies. As we can see from the truth table, the only false statement is the broken promise. Okay, so my broken promise is the only false, My broken promise is the only false statement. Okay, a counterexample is a broken promise. It is going to preserve the hypothesis, but going to contradict the conclusion. Okay, so we have some examples that we are going to answer. So switching over. We have, if a number is greater than 3, then the number is greater than 5. Okay, so which of these is an example of that? So we want an example. So we have, it's going to be greater than 3. Well, that's going to cross off my 2. Okay, but that leaves us with 4, 5, and 6 as possibilities. Then looking at our conclusion, they state the number is greater than 5. So of my 3 here, 4, 5, and 6, the only one that's going to meet both criteria is that 6. All right. And the next one they ask, which of these numbers is a counterexample to that statement? Okay, so we want to disprove it. So remember that hypothesis has to remain true. So we're going to still be only dealing with 4, 5, and 6. But to disprove that it's going to be greater than 5, we will have 4 and 5 as my answers. Okay, then we move into example number 2. If a number is greater than 5, then the number is greater than 3. Okay, so which, if any, of these numbers is an example? So greater than 5. Well, 2 won't work, 4 won't work, and 5 won't because it's not greater than, it's equal. Then the number is greater than 3. So 6 was the only option based off of the hypothesis, and it will also work with the conclusion. Okay, so that's going to leave us with 6. Now, which of these is a counterexample? Okay, so remember, we're only still looking at just that 6. It was the only one that is going to stick with the hypothesis, fulfill that. But we need to disprove that conclusion. Well, none of the examples, because we only have 6, actually disprove it. Therefore, we have none. Okay. Or you could write no counterexample. That's fine too. Okay. So down below, we have, these are conditional statements. And we are going to determine, are they true or false? And if they are false, we do have to give a counterexample. Okay. For these scenarios, you might think of some different counterexamples than what I provide, and that is fine. You might have multiples. I will say I suggest only providing one, okay, just in case you accidentally provide a wrong counterexample. I don't want to count everything wrong, so just provide just one that you are certain of. Okay, so we're going to look here, and we have in number 1, if Jane is your sister, then she is older than you. Okay, so we can say false, making sure that we're answering that first question. Is it true or false? And then providing my counterexample since it was false. Well, she could be younger. Okay, then we have an example number 2, problem number 2. If you are in geometry, you are a freshman. Okay, so remember, you want to consider everybody. So while yes, you might be in geometry and you might be a freshman, is everybody. So this is going to be a false statement. Because we could also have our sophomores, our juniors, or our seniors. Okay, so just writing one other one. I'm going to put junior. All right, number 3, if you are a freshman, then you are in geometry. Okay, so if you are a freshman, is there any other math class you could be taking? Well, you could be taking, so false, Algebra 1. Okay, like I said, this one has a lot of different answers. I'm just sticking to some easy ones that are obvious. All right, so number 4, if your clothes are wet, then it is raining. Okay, well, that's not the only way that your clothes could be wet. Okay, false. Maybe I ran through a sprinkler. Okay, so that's another way my clothes could have gotten wet. All right, so throwing in some math ones here, we've got if the measure of angle E is equal to 36 degrees, then measure of angle E is an acute angle. Okay, so thinking back, we know an acute angle means it is less than 90 degrees. Okay, so that 36 is less than 90. Yes, it is going to be an acute angle. There's no other way around that. Therefore, this is a true statement. Okay, number 6, if a number is divisible by 2, then it is a multiple of 4. So divisible by 2, that's going to be our even numbers. And just a reminder, multiple of 4, okay, that's just going to mean that the number can be attained by multiplying 4 by any other whole number. Okay, so 4 times 1, 4 times 2, all of that. So if a number is divisible by 2, well, we've got our evens. We got 2, 4, 6, 8, 10, and so on. Is it always going to be a multiple of 4? Well, no. Okay, so that's false. And just the last one I came up with, I'm going to say is going to be 10. Could be my counterexample. All right, number 7, if a number is a multiple of 4, then it is divisible by 2. Okay, so multiples of 4, that's going to be 4, we've got 8, we've got 12, 16, 20. Well, all of those are going to be even numbers. Therefore, they're all divisible by 2. So this is a true statement. All right, and lastly, for this section, we have if 2 angles are right angles, then they have the same measure. Okay, so thinking back, 2 angles are right angles. A right angle is equal to 90 degrees. And therefore, since it's always equal to 90, they will have to have the same measure. So this is also going to be true. Okay, now moving into our last section for these notes. Okay, my directions tell me to tell whether the process used is intuitive, inductive, deductive, or none of these. Okay, so I'm going to change my pen color. All right, so number 1, the first 4 times Susan ate peanuts, she became ill. Her mother decided peanuts are bad for Susan. Okay, so there's some evidence to back it up. She has done this 4 other times where she's ate that peanut and became ill. So there is data that we're going based off of, and that means this is going to be inductive. Okay, number 2, a girl is 15 years old. She points out, in 3 years, I'll be 18. Okay, well, if she is currently 15 and we're going to add those 3 years to it, we will always get that 18. Therefore, this is going to be a rule, and so it's deductive. Okay, a boy remarks, if a number is greater than 10, then twice that number is always going to be greater than 20. Okay, once again, this is going to be a math rule. When you double that, so for example, greater than 10, we got 11. Double that, you get 22. And that's going to always be greater than that 20. So we're going to say deductive here. Oops. All right, number 4, a courtroom spectator merely looks into the defendant's eyes before saying he's guilty, I tell you. Okay, so he's just looking into his eyes to come up with that verdict. He has no information to go based off of, so this is going to be that intuitive. Reasoning. All right, number 5, a juror serves on a case in which the charge is speeding. Upon finding out that the defendant has already been convicted several times for speeding, a juror murmurs to himself that speeder is guilty. Okay, so it's kind of like that scenario from number 4, but the big difference here is going to be the fact that he has already been convicted several times before, and they're kind of telling them that. So we're going based off of a pattern here, and so we'll have that inductive reasoning. All right, so number 6, we have the music director announced anybody who misses 2 or more rehearsals will not be allowed to sing in the concert. Okay, so after being out of town during 3 rehearsals, Herb said, I can't sing in the concert. Okay, so that music director, he made a rule, and therefore we are going to say that this is going to be our deductive reasoning. Okay, now number 7, we have Elmer said to himself, I was late because the bell rang early. Okay, that's not really using any reasoning. He's kind of just stating a fact. And so because of that, we are going to say that this is going to be none of these. All right, so that was the end of our patterns and kinds of reasoning lesson. Hopefully you find this video helpful.